Welcome everyone to today's Royal Cyber webinar on improving performance with SAP Commerce Cloud. Let's give another 30 seconds for any last minute attendees getting on before we get started. All right, well, let's get started. Hello everyone, my name is Alfonso Ashuaje, Business Development Manager of our e-commerce services here at Royal Cyber. It's my pleasure to welcome you to today's Royal Cyber's webinar session. For today's agenda, we're going to cover a couple of different subjects. So let's start with the importance of performance, the wrong assumptions about performance. We're also going to cover the standard approaches to improve performance, the tools used in standard approaches. And also we're going to cover a little bit more about Royal Cyber's advanced strategies and our customizations, as well as we're going to have a Q&A session. That being said, go ahead and have your questions. Any questions that might come up through this presentation ready for the Q&A session at the end. In addition, we're going to have a special offer for all attendees today, so please stick around to the end to hear a little bit more about this exclusive offer that we're going to have in today's session. So before we deep dive into today's session, I would like to formally introduce Royal Cyber and our lead presenter, Jagannathan Sadasivan. Now, some insights on Royal Cyber. We have more than 1,000 employees across the globe with development centers in India, Chennai, and Bangalore, and a strong development team also here in the United States, headquarters in Naperville, Illinois. Now, as far as our e-commerce technology partnerships, they span from SAP Commerce Cloud, Magento, HCL, to Salesforce Commerce Cloud, among others. And in addition to our e-commerce partnerships, as you can see here, we also have a strong presence and expertise in cloud, big data, mobile and mobile commerce, artificial intelligence, machine learning, middleware, DevOps, portals, you name it. So we're happy to say we have teams specialized in each of these areas. Now, you might see the title of this webinar, and you might recall earlier last year, we hosted a high-level webinar on performance. Now, as industries and technologies continue to evolve, taking in consideration the unexpected events of this year, we actually wanted to host a new webinar to dive deeper into the key performance areas to monitor and optimize to improve customer experience and increase conversion rates and customer engagement. Now, it's my pleasure to introduce you to Jagannathan. He is a performance architect and senior e-commerce administrator for the past 8 years and has over 16 years of IT experience. So with this brief introduction, let's go ahead and direct our attention to Jagannathan.
Thank you, Alfonso, and welcome everyone for being here for today's webinar. So I will start with the importance of the website performance. So there were several researches done to see the impact of the website performance. At most, all the research came with the same conclusion, like the website performance is kind of directly related with the revenue of the site. And there were A/B tests carried out, like to see, for the group of users who had the performance issue and the group of users who had a good performance, and what is the conversion rate between these two groups. So the conclusion was the users who had good performance had had higher conversion rate compared to the user groups who had the poor performance. Also, the site with good performance, it gets more recurring users. It keeps the users more engaged. It makes the users to navigate more pages, and it creates recurring users. Just for the sake of discussion, I would like to share some of the statistics. So every second of improvement in the load time decreases the bounce rate by 7 to 10%, increases the conversion rate by 7 to 10%, and increases the user engagement by 10%. So you might be already familiar on these terminologies. What is a bounce rate? What is conversion? What is user engagement? But just for the sake of discussion, I will take a minute to describe about them. So what is your bounce rate? So user get into a site and without navigating any more pages, user quit. That is bounce rate. So if the bounce rate is higher, then that means the site is not good. And what is the conversion rate? The percentage of the users who placed the order. So that is the conversion. And what is the user engagement? Say the user get into the site, navigate some pages, and then quit. This whole tenure, that is called a session. So a number of pages visited in a session, that is called user engagement. So when the user visits more pages, that indicates there is a chance that the user may place an order. So if the site which is having a good user engagement, then that is good, that creates opportunity for more orders. And 30% increase in performance increases the conversion rate by 5 to 10%. Again, so the performance is related to the revenue. When I say conversion rate, that indirectly means revenue. And boosts the ranking in the search engine result. So what happens? So when somebody is searching, so we get somebody is doing search in Google, so we get several pages, meeting the criteria. So which page comes first, which page comes second? If you think practical, right? So when we get several results, so most of the people click the first page in the result, and then goes next. So the top 3 pages get good hits from the Google search result. So one of the criteria which search engine use for the ranking which page to come first is the performance. There are a lot more to discuss about the important the performance, but I'm just highlighting some of the key data. Some of the wrong assumptions about the performance. So assuming load is causing the performance. So many times when the site is when the performance is poor, we think like the load is high, so the site is having the performance problem, and trying to solve the performance issue by increasing the order. So this is the another assumption. So I'm going to add like couple of more servers, then my performance issue will get solved. Always trying to improve the coding. So this is another approach, like when the performance issues there, involve a developer to see what is happening in the code. And functional issues are more important than the performance issue, because for functional issue there is always somebody waiting from the business side. Even though that the functional issue is less significant, since somebody is waiting, so we try to give more attention to the functional issues. But performance issues are, remember, the performance issues are directly related to the revenue. So I'm not telling these are wrong, these are totally wrong, but instead of taking speculative approach, like trying to increase the hardware, or to improve the coding, we have to take a systematic approach. That's what I mean to say. So first, this webinar I'm going to cover in two part. First is standard approaches to improve the performance, and then our advanced approaches. So when it comes to standard approach, first we need to narrow down the problem. So what is narrowed down the problem? So the performance issue can happen on the server side or browser side. First, we should classify whether the issue is on the server side or the browser side. So how we come to know whether the issue is on the server side or browser side? So let me explain with a small example. So if you take this, right, so when the user hit the site, there are numerous requests being fired from the browser. So the first request which is getting fired, right, that directly goes to the server, and the server responds with something called a document. So this is called sometimes people call it as document, or people call it as document object model. There's a DOM, or some people call it as HTML. So this document, this has all the important crucial information needed for the site. So be it like a price, or whatever the list of products, facades, everything is going to be. And what are rest of the things? Like these are rest of things are like JavaScripts, or cascade style trees, or could be images, or third-party related things. So we could see this document here, the response time is 927 millisecond, and at the bottom the load time, that is 3.7 second. So that means we can say the server side response for this page is 727 millisecond, and the rest of the time, that is 2.8 second, was taken for doing the rendering, so involving the JavaScript, style sheets, and images. So the browser executes the JavaScript and style sheets to do the rendering to create the page. So if the server side, the document response is higher, then we have to give attention on server side performance optimization. But if the server side performance is okay, but the browser side, the load time is higher, then we have to give more importance on what is happening on the browser side. So I would say, as long as it is like around the maximum 700 millisecond on the server side, that is acceptable. But if it goes beyond, then we have to give some attention. If it goes beyond like 1.5, in fact beyond 1 second itself, I would say we have to give some attention on the server side. And the load time, the expected the expectation is the load time should be less than 3 seconds. That is the standard expectation. When it is when the response is slow on the application server side, it could be either related to the hardware or it could be related to the application logic. So when it is a hardware, right, there are two classification here. It could be like the servers are not having sufficient hardware, or the servers are having sufficient hardware but they are not allocated to the JVM process. So when it is application side, it could be database related or coding related. Okay, so how we narrow down whether it is a hardware issue or whether it is a logical issue? So when it is, the first place we look at is we look at the dashboards, like the application provided dashboard like admin console or the Grafana, like the monitoring tools dashboard. That will give the very good indication. And on top of that, we can do thread dump analysis, heap dump analysis, or garbage collection analysis. Or sometimes we may have to revisit the JVM params like heap settings to ensure the JVM is allocated sufficient hardware. And then we also need to do the traffic analysis. That's very important. So what happens, right, our site gets like, believe me, for one of our customers, 70% of the site is from the bots traffic. So they are not real user traffic. So the bots play vital, considerable amount of traffic comes from the bot. Sometimes we also get a lot of traffic from malicious user. Somebody runs some script for experimental purpose, or somebody want to see, to slow down the site, they generate abnormal traffic. So on that case, we have to control the traffic. We have to go for like web application firewall to control the traffic, to block the malicious traffic. And finally, if we are not able to solve by any of the configurations or by controlling the, then finally we go for scaling the hardware. That is the final step. And when it comes to the application logic, it could be on the database side or it could be on the logic. So when it is on the database side, there could be two possibilities from our experience. So it could be like the database might be missing the indexes on some of the columns, the database columns, or it could be large volume of data. So when it is we came across a scenario like a customer had like a product had around like 3,000 children product, or the category had numerous products under it. So that caused performance issue. So we had to work with the business team to restructure the product such that a product will has only limited number of children. So that kind of approach also we may have to take some time to solve the performance issues. And the logical issues we will discuss further. Okay, when it is on the browser side, from our experience, the browser side performance can be of, because of three reasons. One is image loading, or it could be because of third-party integrations, and it could be because of JavaScript processing. So image loading. So when it is image loading, right? So the common trend is the business plays the image in the form of like JPEG file or PNG file. So obviously the JPEG or PNG file, from our experience, they are like 100 kilobyte or 200 kilobyte inside. So imagine there are like 30 images in your page. So the browser end up like pulling like 3 megabyte of data from over the network for that many images. Also it has to render it into the page. So that is one of the reason for browser side performance issue. And another reason is the numerous third party integration. So right now what happens is that now the trend is through Google Tag Managers, we are business is able to inject the third parties. So without letting the development know, without even involving the development, so the business can inject the third parties through Google Tag Managers. Numerous third parties, they approach the business, okay, inject the couple of lines through Google Tag Manager, so we will we will take care of rest of the things. So as a result, the business keeps injecting the third parties through Google Tag Manager, or there are other ways also without involving the development. And remember, the more third parties being injected, that will cause the browser side performance. So we have done one experiment for one of our customers. So we had the performance issue. So what we did is, for whole day we shut down all the third party integration. We switched off all the third party integration. We disabled all the site was very fast after disabling it. So that happened, that proved like the third party integrations, they slow down the browsers, the performance on the browser side. And third reason is JavaScript processing. So what happens with the current trend is like the applications like Hybris, they provide options to consolidate the JavaScript. So what happens, what the browser get as a JavaScript, like 1 or 2 files, but they are very larger in size. So the browser uses only like 10% of the JavaScript. So so these are all the three reasons which could cause performance issue on the browser side. These are some of our approaches to handle this, to handle these issues are like, so when it is image loading, right, we can take lazy loading of images. So what is lazy loading? Let me quickly explain a small screenshot. So let us take this page, right? So if you see, if you see this vertical scroll bar, so the user has visited like only like 25% of the page. So remaining 75% of it, he did not scroll down. So what happens when the page is loaded, by that time itself, we load everything needed for all the, even the remaining 75% of. So the lazy loading means only when the user scroll down, that time we load the resources like images corresponding to that section. So that is lazy loading. So we can take such approach and serving images in the next gen formats. So instead of serving in the JPEG or PNG format, there are next generation formats like WebP. So that provides like 1/10 of the size of the JPEG format. So and with at most reasonable good resolution. So that kind of approach we can take. And then there are image managers. So what the image managers do, they sit on the CDN. The CDNs like Cloudflare or Akamai, they provide the image manager service as like add-on service. So they provide like two approaches. One, so based on the end user internet speed, the image size will be served. If the end user internet speed is slow, they classify like slow speed, medium speed, or high speed. So if the end user internet speed is slow, then serve in the like 50% compressed. So the CDNs will maintain already the three varieties of the image, like 50%, 70%, or 90%, something. So for what to serve for slow internet speed, what to serve for medium, and what to serve for good internet speed. So based on the end user internet speed, they serve the appropriate image resolution, the images with the compressed images. So that kind of approach we can take. And when it comes to third party integration, first thing, avoid unwanted third party, injecting the unwanted third parties just for experimental purpose. And we can also control like certain third parties to be excluded from certain pages. So that kind of approach. And we can do lazy loading of the third parties. And again, for JavaScript, so here also we have option for lazy loading, but we have to be little careful about, there are conditions like which JavaScript can be lazy loaded, which cannot be. So these are all some of the tools we use to narrow down the problem and optimize. Dynatrace and AppDynamics, these are leaders for APM tools. So they are helpful in analyzing the server side performance. And Splunk and Kibana, they are like the log monitoring tool. They're very popular in the market now. So we can pull a lot of metrics on the performance from Splunk and Kibana. And Grafana is the application, the server side monitoring, like the server's hardware utilization. We can, so there are other alternate tools as well, but I see many customers use Grafana. And Hybris admin kernel, that's a very good place. We can do like a thread dump analysis and database analysis. There are a lot of analysis we can do Hybris admin console. I use a lot of time Hybris admin console to narrow down the problem. And we can use thread dump analyzer, heap dump analyzer, and garbage collection analyzer. And we use Google Analytics that also provides performance metrics, and Google Insights. So if a particular page is slow, then we can analyze that why that particular page is slow in Google Insight. Jota, this is used for browser side performance optimization. And GT metrics, that's again like Google Insight. And our standard Google developers and Firebug. So these are all some of the tools, just to name a few. Of course, there are a lot more than this, but these are frequently used. We use these tools frequently. Okay, so far I was discussing about the standard approaches, that is like narrowing down the problem and applying certain standard strategies. So for the rest of the session, I will discuss about our advanced strategies and customization. So here I would like to discuss like 5 of our approaches. So one is full page caching using CDN, and performance optimization using custom caching in the application server, and centralized or distributed caching, and performance optimization by maintaining pre-formatted data in the search server, and usage of Ajax call. Okay, full page caching. using CDN. So before getting into what is full page caching, just would like to give some detail about CDN. You might be already familiar, but just for the sake of discussion, just would like to give few information. So what happens? So when the user hits a page, first the request goes to CDN. So the CDN will have numerous servers spread across the globe. So the server which is the DNS resolution happens when the user hit a page by the DNS server. So the DNS resolution will give the nearby CDN server. So the request will go to nearby CDN server, and then the CDN will route the traffic to load balancer, and then Apache Web Server, Hybris, and finally database or Solar, whatever which Hybris interacts with. So the main purpose CDN serves is the static page caching. So typically CDNs are meant for doing the static page caching. So what is static page caching? Caching the images, CSS, and JavaScripts. So because why? So we cache them because there are two reasons. First, they don't change frequently. If you take images, they are not getting changed several months, sometimes several years also. And when it comes to JavaScript and CSS, they are changed once per deployment. And also the number of JavaScript and CSS are very less. The application might have like hardly 10 or 15 JavaScripts and CSS. But when it comes to like product pages or category pages, there are numerous. So the dynamic page caching or full page caching, right? Let me explain with a small example. So let's take this page. So I think I already shared this screenshot in a prior slides. So the first response which we get, that is from the server. So the rest of things are like the static files. So we are caching this. So this is what full page caching. So we are caching what is being served by the server. So we are caching from the we are serving it from the CDN level. So the moment we think about full page caching, right? So some of the questions which come, right? So if I cache a page, so what if the page is modified in the backend? And what there may be items which are modified frequently, right? And there may be some user specific contents. So if you take this, right? So if you take this page, so you take this as a user specific content, and then the stock information and the minicart detail. These are all user specific information. So what happens to that? So if I cache this page and serve to several users, then will they get the same user detail? So we handle that by using the Ajax calls. So what happens? Whatever the information which are modified frequently, like stock information, which are modified as and when the users keeps placing order in the backend, and the user detail which varies for each user, and then the mini cart detail, which are of course different for each. So we use Ajax call. So what happens? The main the response which server is giving the document. So in the document, we will not have the information for these items. So there will be instead the document will have further calls like reference to pull the information. So these are called Ajax. The people from technical background will be familiar on what is Ajax. So we use that to pull the dynamically changing content. And another thing is, say, what if the content is modified by, say, for example, business users may go and change the price for a product. So then so how we handle that? So we have created cron job in Hybris. So what happens? The cron job runs like every 15 minutes, and it pulls a list of products modified in the last 15 minutes. So Hybris maintains the modified timestamp for all the tables in the database. So based on that, we pull like last 50. So as and when the cron job runs, it pulls the last 15 minutes modified products, and then it frames the URLs for those products, and then CDN provides the API method to clear the cache. So the cron job calls uses that API by providing the list of product URLs, and CDN clears the cache. So I would like to show a quick demo on the outcome of the this full page caching. So let's take a product page. I hit the page. So right now it is cached in the CDN. So the response time is 39 milliseconds. So just for the sake of, so CDN cache, for CDN, this is the URL is the key. So just for the sake of discussion, let me make the URL as unique, so that the server will still reply to the still respond for the same product page. To just to make the URL unique, I'm introducing some query string with some random number. So CDN will find, okay, I don't have the content for this page, it will route it to the backend. So now the request, so we could see the backend, the response time from the backend is 2.04 second. Now the content will be cached by the CDN. So I hit again. So we could see 124 millisecond. So I again hit, you see 35 millisecond, because now the response is coming from CDN. So for the sake of discussion, so I make the URL as unique. Now the request goes to server. So we see 1.8 second. So this is one page. So let's take another page. So now this is a response from CDN. It's already cached. So let me make something like unique. So now the request goes to the server. Now the response is 4 seconds. So now it comes from CDN. Response is 240 milliseconds. So when the content is served at the CDN level, we see the response in around like 100 or 200 millisecond. But when it goes to server, the response time was high. So these two pages are somewhat heavy in nature. So I use them for the demo purpose. Okay, this is the small flow, what happens when we use CDN. So for example, first the user hit a product page, so the page is not in the cache, so CDN routes it to the Hybris or backend and gets the result, and then cache it and then reply to the user. So next user hit it, now CDN has the content in the cache, it doesn't send it to the backend, and it replies from the cache. So say after some time, so the caches have the expiry. So let us take, for the sake of discussion, so like 1 week as a expiry. So within 1 week, so somebody from business update the price, and then so what happens, our cron job runs, and then it sends the request by calling the API, CDN's API, it clears the cache, and then the cache is cleared. So the another users hit the same product PDP, the product detail page, the content is not in the cache, so CDN routes it to the origin, and again cache it and respond to the user. This is a small workflow. Okay, on top of that, say for example, we use Akamai as a CDN. So Akamai provides something called pre-freshing. So what is pre-freshing? So ahead of expiry, getting the fresh content from origin, or refreshing the cache ahead of the expiry time. So I can explain it with a small example. For example, say expiry of the cached content is 1 week. So I set the pre-freshing as a 1 day. So what happens, right? So I hit the page now, the page is cached, and then after 24 hours, so till 24 hours, whoever hits the content will be served from the cache. So after 24 hours, when the first user hit for the page, so what the CDN will do is it will serve the content from the cache, because the expiry is 1 week, so the content is still valid. Parallelly, it will get the fresh content from the backend and keep the cache refreshed with the fresh content. So the user will get the content from the cache, so he will get the response faster. At the same time, CDN gets the fresh content from the backend, and then it updates the expiry to be further the 1 week from that point of time. So thereby CDN keeps updating its content fresh, also keeps extending the expiry. So at a given point of time, there is a high chance the content will be in the cache. Also the maximum the outdation maybe 1 week. So this is a small illustration for the pre-freshing. So the user hit a page that is not in the cache. So that is, the CDN gets it from the backend. We call it as origin, and have it in the cache and supply to the user, respond to the user. Within 24 hours, the another user hit. Yes, CDN serves from the cache. And after 24 hours, the first user hit. So CDN serves from the cache. Also, it gets from the backend fresh content, and then extend the expiry for next 1 week. So again, the flow continues. So what is the final outcome? So we get, this is for the last 1 month, what we noted around 83 percentage heat ratio. So so out of 10 requests, we can say around 8 requests are served from the CDN level. Okay, that is about the first strategy, that is performance optimization by full page caching through CDN. And the next approach is performance optimization using custom caching in the application server. So what is a custom caching? I think the people from Hybris development background will be familiar. Hybris is having the out of the box caching. So what happens is that out of the box caching, it caches the individual types. So like a product is a type, so it caches the product. Price is a type, so the price, the cache is maintained separately. And stock is a type, so the stock cache is maintained separately. So what happens, the caches are maintained in chunks in a separate entities. So there are so what happens when we have a very large volume of records, so sometimes our logic may be using combination of this price, product, and inventory. So we may have some internal objects which is combination of price, product detail, and inventory. So on those kind of cases, the out of the box caching of individual entities are somewhat ineffective. So what we did is we built our own custom caching. Hybris provides option to build our own custom caching. So that is another approach we use. So this is a end result for when we used such a custom caching for a couple of items. So we got around 75% hit ratio. So for first case, it's like around 150K hits, and then for the second case we got around 1.7. It just maybe like for a duration like maybe couple of weeks of time. So this is another approach we use to improve the performance. So obviously when the custom caches are used, we are avoiding a lot of invoking several chunks of caches, also avoiding the database calls. So the third approach is the distributed caching. So what is distributed caching? So out of the box Hybris, right? So what happens in the out of the box Hybris, every server builds its own cache. So if you have like 5 servers, then every server builds its own cache. Also, when the servers are restarted, then the cache is lost. Also, what happens, the warm up time is also high for every item, every server to build the cache. So so there is something called a distributed cache. So Hybris uses cache framework. That is a framework for maintaining the cache, for building the cache. So there are providers like Terracotta, that is one of the popular vendors. So they provide a centralized mechanism for maintaining the cache. So the centralized server for maintaining the cache. So what happens with that approach? So the individual servers will not maintain the cache, inside the server. Instead, they will maintain the centralized server. So the cache built by one server will be utilized by all servers. So whenever a server is in need of an object, instead of framing the database query or applying the traditional approach, first it will check whether the object exists in the centralized server by making a get request. So if the object exists, then just use it. Otherwise, build it and put it into the centralized server. So this approach has several advantages. So first thing, the hardware utilization on the each server will be drastically reduced. So if we take a heap dump on any server, right? So if the server is having like a 16 GB of heap utilization, when we take heap dump, we could see around 12 GB are utilized purely for caching purpose. So if we maintain the cache in a centralized server, then we are excluding the 12 GB of memory. So we are able to run the Hybris server with very less hardware and less CPU. Um, Also remember, this cache server, it is not a Hybris server at all. The cache is the standard, it is built using the standard Spring framework. So this is totally not a Hybris server. Of course, the Terracotta servers, they require licensing. That's different. So there are several advantages of going by. So we reduce the hardware utilization on the individual Hybris servers. Also, the cache warm up is not needed because we are maintaining a centralized server, and we don't need to worry about restarting the server. the caches will not be lost. Also, we don't need to worry about vertical scaling. We can keep adding. Typically, we don't recommend the horizontal scaling. Sorry, when we add servers, more servers, we don't need to worry about cache warm up. Typically, we don't recommend a horizontal scaling, because what happens when more servers we add, each server will take their own time to warm up the cache. Also, the communication, sometimes the communication between the servers, like the invalidation and all, so that leads to high traffic between the servers. But when we go for a centralized cache server, so that kind of bottlenecks are avoided. So that is the third approach. The fourth approach is performance optimization by maintaining the pre-formatted data in the search server. So what happens, right, when some pages are slow, right, so some portion of the page is causing that slowness. So we noted for one of our customer, so a page was having this kind of a product page was having this kind of specification, like a matrix kind of specification. So to build this matrix, the Hybris out of the box has to iterate all the children product. So there are cases of there are a single product is having numerous children product, and that led to huge performance problem. So we decided to maintain this whole matrix in the Solar server. So we created a separate core in Solar, and we built the index to have the data ready in the Solar. So we have the delta index and then the full index. So as and when some table related to this structure get modified, then the delta indexing will update and push the index to the server. Also, we have weekly full indexing. So what happens, the data for this table is available readily in the Solar in the pre-formatted way. So when the page is loaded, the application need not run the logic to create this data every time. Instead, it can just call a Solar query and get the already created data. So this is just an example of such a data maintained in the Solar. And the final approach is the usage of the Ajax call. So again, similar to the example I showed, there are cases, some sections are having heavy data that takes high processing to prepare the data for that section. And say there are sections like they don't get the user attention immediately. The user go to that section only on some cases. For example, this is one case. So the product detail page is having this section called all model that maintains the siblings information. Basically, the other products comes under the same family. So that this section usually only few users go to this section. So for also the user who land into the page, they don't immediately go to that section. So we use the Ajax methodology. So what happens when the page is loaded, the main response coming from the server to create the main response, the server don't need to spend time on creating this structure. So instead it will have the reference URL. So it goes to the page goes to browser, the response goes to browser. The browser makes separate call in a lazy loaded way to pull this information. So the user so when we do that way, the user will not feel the slowness. So these are all the 5 strategies. So there, of course, there are some more strategies, but for our discussion, I'm highlighting the 5 strategies. So just to summarize the outcome, so when we use the full page caching at the CDN level, we are eliminating around 60 to 80% of the traffic. So the rest of the 20 to 40% of the traffic hit the backend. So in the backend, we have like a 3 logic: the maintaining the pre-formatted data in the search server, also the custom caching. Also, we have the process for distributed caching. So with this, we are able to avoid a lot of the database calls, and that gives a very good performance improvement. Yeah. So
Awesome.
with this, I hand over to Alfonso.
Awesome. Thank you, Jagannathan, for your time and for giving us that in-depth look into best practices for improving web performance with SAP Commerce Cloud. As I mentioned earlier, as part of our webinar, we're offering to all attendees and registrants a 1-week complimentary performance assessment. Now, this assessment is going to be great, especially during this time, as many companies are struggling with their budget and trying to find a different way to really enhance their performance without having to go all the way out and actually do any implementations or upgrades. So this complimentary assessment is able to take a look into your infrastructure, We do a traffic analysis as well as a log analysis. We of course, Janagapan pointed out, we go through all the catching as well as the application performance and search performance. So really, really, really hope that you and your team can take advantage of this offer.